Hello everyone, welcome back to Pixel Developer. In today's video, we're diving into one of the most powerful libraries in Android Jetpack, WorkManager. If you've ever wondered how to handle background tasks like syncing data, uploading files, or running periodic operations seamlessly in your Android apps, then this is the video for you. So, without any further delay, let's dive straight into the introduction of WorkManager and explore how it can revolutionize background task management in your Android apps. Background tasks like syncing data, uploading files, or performing scheduled operations are crucial for many apps. However, challenges like device restarts, app closures, and strict battery optimization policies make managing them reliably a complex task. What is WorkManager? WorkManager is a modern solution for handling background tasks in Android. It's not only reliable but also respects system constraints to ensure battery efficiency. Features of WorkManager: guaranteed execution. WorkManager guarantees that your background tasks will complete, even if the app is closed, crashes, or the device restarts. This reliability makes it perfect for critical tasks. Persistent work. It's designed for tasks that need to persist over time, like syncing data or uploading logs. Once in queued, the tasks will run even after a device reboot. Deferrable work. For tasks that don't need to run immediately, like sending analytics or reports, WorkManager ensures they execute when conditions are right. Power optimizations. To save battery, WorkManager uses efficient mechanisms like Job Scheduler or Firebase Job Dispatcher based on your device's API level. Constraints. You can specify conditions for task execution, like running only on Wi-Fi while charging or when storage is available. This gives you complete control over resource usage. Components of WorkManager. 1. Worker. The worker class is where you define the actual background task logic. 2. Work request. This specifies the task type, either a one-time request or a periodic request for recurring tasks. 3. WorkManager. The singleton class that handles unqueuing and managing all your work requests. 4. Work info. It provides real-time updates on the current state of your work, such as success, failure, or in progress. Let's talk about the different states of WorkManager, which help you track the progress of your tasks. 1. Enqueued. First, we have the enqueued state. This means the task is scheduled and waiting for the right conditions to start, like network availability or charging. 2. Running. Once those conditions are met, the task moves to the running state, where it is actively being executed. 3. Succeeded. If everything goes as planned, the task enters the succeeded state, indicating it completed successfully. And failed. But if something goes wrong, the task moves to the failed state, and it won't be retried unless specifically configured to do so. Blocked. Sometimes a task might depend on other tasks. In such cases, it stays in the blocked state until those dependencies are finished. 6. Canceled. Finally, we have the canceled state. This happens when the task is explicitly stopped, either by the app or the system. Understanding these states helps you monitor and debug your background tasks effectively. With WorkManager, you can set constraints to control when tasks should run. For example, you can specify network conditions like being connected or unmetered, require the device to be charging, ensure storage isn't low, or even wait for the device to be idle before starting the task. Now, let's talk about how WorkManager works. Here's an example of a worker class where we define the task logic. If the task is successful, it returns result.success. If it fails, we use result.failure. And in case of an exception, we tell WorkManager to retry with result retry. Simple, right? Simple. The next step is to create and in-queue a work request. This tells WorkManager what task to run and when. For example, you can use a one-time work request for single tasks or a periodic work request for recurring tasks. This code observes the state of a WorkManager task and logs different messages based on whether the task is in-queued, running, succeeded, failed, blocked, or canceled. It helps track and handle the task's progress and outcomes in real time. Compared to other libraries, WorkManager is more robust and feature-rich, making it the best choice for most background tasks. WorkManager is designed for tasks that can be deferred and are not immediate, with a minimum interval of 15 minutes between executions. Execution timing may vary due to system optimizations, so it's not suitable for precise or time-critical tasks. WorkManager simplifies background tasks with a single API that works across various API levels and handles app restarts and device reboots. It's thread-safe and lifecycle aware, making background work more reliable and efficient. That's a wrap for today's video. In this session, we've covered the basics of WorkManager, its flow, and how it works. In the next video, we'll dive straight into implementing WorkManager in an app and explore more advanced use cases. If you found this video helpful, make sure to hit the like button, subscribe for more content, and follow us on Instagram, GitHub, and other social media platforms for updates. Thanks for watching, and we'll see you in the next one.